Okay, so one-way slab design tayo. So, what is a one-way slab before we start? Okay, so imagine this figure. A slab that is supported on both end sides, like this one. Okay, so if we will look at this in this isometric view, a one-way slab is defined as a para siyang beam, no? It is like a beam, a wide beam that will bend in only one direction, like this one. Okay? So ito yung manner of bending ng one-way slab. Sa isang direction lang siya nag-bend. Okay, so it is resisting a bending moment about this direction. So this is the cross-section to be considered when mag-a-analyze tayo ng one-way slab. No? So basically, one-way slab are considered as wide beams that bends in one direction only. Okay, so this is an example of a one-way slab detailing for reinforcement. So we have here at the midspan, the bottom bar, and as you can see, it has a bended up bars dito sa itaas because at this portion, the slab is resisting negative moments. Okay? So anyway, hindi naman natin i-discuss furthermore yung detailing section dito. We will discuss the analysis of a one-way slab and how to design this one. Okay? So, as you can see kanina, one-way slab, theoretically, that is a slab that will be supported on two spans lang. But in design, even though the slab is supported on the four sides, we have the rule of thumb if i-consider ba natin siya as one-way or two-way slab. Okay, so consider this example. Assuming we will be analyzing the slab A, B, D, E. Okay, so on the rule of thumb, we have to compute the ratio of the long span to the short span. In this case, that will be L over S should be greater than 2.0. Pag ito yung ratio natin will exceed 2.0, then we will analyze that slab in like a one-way slab, no? Even though may support tayo in all four sides. Because in reality, theoretically, if may supports yung slab natin in four sides, then magbe-bend siya in two-way talaga. Okay? But since yung distribution ng ating slab to the beam, that will be 45 degrees here. Let me draw na lang. No? Ganito yung distribution kasi niyan. Ito yung distribution ng slab to the beam. We have the loads here, then it will be distributed to the beam dito, like this one. So as you can see, ang magbe-bend lang dito sa shorter span is napakaliit lang na part ng slab. Ito yung magbe-bend through at this portion, at dito rin. But for the long span, mas malaking portion ng slab ang magbe-bend dito, that one. Kaya we can use this rule of thumb to compute the ratio in order for us to determine if i-design natin siya as a one-way slab or a two-way slab. So ito yung rule of thumb natin. If exceeding siya yung ratio to by 2.0, then we will consider this one as one-way slab. Otherwise, two-way slab yung analysis natin. Okay? Okay. So, basic steps in one-way slab design. Okay, so by the way, these notes pala came from the ASEP, the Association of Structural Engineers of the Philippines. Okay, from one of the seminars ng ating ng organization, no, dito sa Cebu. So this came from them, yung mga napakalakas na structural engineers sa Pilipinas. Okay. Okay, so we have, and by the way, so basic steps, of course, first step, we need to choose the slab thickness. That is for us to control the deflection. Yan yung pinaka-una nating gagawin. Then, number 2, check if the thickness is adequate for the shear. Then number 3, calculate the positive and negative moments in the slab. And number 4, design the reinforcement. Of course, ito yung ginagawa natin, to design the reinforcement sa ating concrete. Okay, so in this section on the NSCP 2015, so we have the table of the minimum thickness of the solid non-pre-stressed one-way slabs. So ito yon. Okay, so we have simply supported, so magagamit natin ito mamaya on our sample problems. Okay, so in calculating naman the factored shear and moment, of course needed natin yan in order for us to design the concrete, the moment and the shear. Okay, so as we all know, we can calculate the maximum moment and the maximum shear on the frame or in the slab by using theory of analysis, no? But the code suggests or allows us to use the simplified method of analysis for non-pre-stressed continuous slab. Okay, inaalaw tayo ng code na gumamit nito because we all know that very tedious yung calculation natin for the theory, no? Sa pagkuha ng maximum shear and moments, napakahaba ng solutions, kaya may alternative yung code natin, which is this one. Yun nga lang, dapat natin i-satisfy muna ito. We have to satisfy this all para magamit natin ito. Okay, so example, design the slab ABDE if the dead load pressure is 5.19 kPa and the live load pressure is 2.4 kPa. So we have the FC prime 21 MPa, Fy is 345 MPa, then the beam dimension is 300 mm by 500 mm. Use 10 mm diameter main bars. Okay, so ano yung una nating gagawin? Okay, first step, of course, we need to check the rule of thumb, no? The ratio of the long span over the short span. That is for us to determine if i-design natin to by one-way or two-way slab. Okay, so this is the ratio, and that is long span over the short span, which is 2.8, and that is 2.14. Now, as we can see, that exceeds 2.0. Hence, one-way slab is adapted in this case. Okay? Exceeding siya ng 2.0. Next, step 1, yung pinakita natin kanina, of course, choose the slab thickness to control the deflection. Okay, so ano yung criteria natin? Di ba ito yun? Minimum slab thickness. So here, we have for support condition, ito yung i-base natin or pagpipilian natin. Now, as you can see, the problem requires us to design the slab A, B, D, E. So we need to focus on this slab. Okay? So paano ba natin i-analyze yung slab, by the way? Okay? So in this case, take note that if ito yung slab na i-consider natin, we are considering a 1 meter strip ng slab. Yan yung analysis natin dito. Okay? So ito yung strip na gagawin natin. 1 meter strip yan. Okay? So yung length natin dito, as you can see, may L that is considered as the length of the member. So since this slab will bend in this direction, parang naging beam siya na 1 meter yung beam width, ganito. So ito yung i-consider natin na length niya, yung pahalang sa kanya, I mean perpendicular sa ating beams. Yan yung length ng ating slab dito. Okay, that is 2.8. Well, if yung beam yung i-consider natin or i-design natin, then the length should be this one. Pag slab, yung length natin is perpendicular dapat sa beam because ito yung kino-consider natin na member dyan. Okay? So, since ito yung slab na kino-consider natin, then we need to consider this one. Okay, so on the first section, simply supported. Now, as we can see, the slab is not simply supported. The slab is assumed to be fixed when it is attached to a beam. no? So in this case, yung slab natin naka-fix yan lahat dito. That is the assumption of the code. Unless na lang if i-specify sa problem na hindi siya naka-fix or nakapatong lang siya sa wall. Okay? But in most common cases, naka-fix talaga siya. Now, the second one, ito yung gagamitin natin. Because that is one end continuous. Bakit one end continuous? Okay, so consider this slab lang dito, ABDE. So, at this end, wala na siyang continuation dito. Okay? But the other end, may continuation siya. Yan yung ibig sabihin ng one end continuous. Okay? This both end continuous, ibig sabihin yan, itong center span natin. Both may continuation siya sa dito sa taas and dito sa baba. Okay? So, cantilever, I know, alam nyo na yan, no? Okay, so in this case, one end continuous, then the minimum thickness H is given by this formula, L/24. And by the way, my statement dito for Fy higher than 420 MPa, the expression shall be multiplied by this factor. Okay, so checking our Fy, that is 345, that is lesser than 420 MPa. Then we will not be needing this factor na. Hindi natin to gagamitin. Okay, diretso na tayo dito, L/24. Take note, our L is this one. That is 2.8. So, converted this to millimeters, 2,800 millimeters divided by 24, and that is 116.67. Of course, i-round up natin yan para mas maging safe, no? So, maybe I will just use H equals to 120 millimeters. Okay? It's up to the designer. Pwede natin gamitin 125, 130, or kahit mas mahaba. Okay? It's up to us na lang talaga. In this case, gagamitin ko lang 120. Okay? So, we have the value of H. Now, step 2, check if the thickness is adequate. This should be is adequate for shear. So, we need to calculate the shear at the ends dito. The factor shear. So, let me calculate first the uniform dead load. Okay, the uniform dead load, factor dead load. Okay, we have the factor here, 1.2. The pressure is 5.19. But take note, we are considering 1 meter strip dito. Or kahit gawin nating 6 meters yan, the same lang yan, yung lalabas natin na design mamaya. Kasi spacing yung dinedesign natin dito. Kahit gamitin natin yung 6 meters dyan or kahit anong length, the same pa rin yung lalabas. But for simplicity, 1 meter strip talaga yung advisable para mas madali. Okay? So, pag nag-unit analysis tayo dito, this is kPa multiplied by meters, then the unit will be kilonewtons per meter. Okay? Then the factored live load. So, take note that the factor coefficient dito is 1.6. So, 1.6 times the live load, 2.4. Again, 1 meter strip, and we have 3.84 kilonewtons per meter. Now, the total factored load, i-add lang natin yung dalawa. Okay, 6.23 plus 3.84. That is 10.07. Now, we can calculate the factored shear, no, because of the factored loads by using this table on the NSCP. Okay, so don't worry ha. Ibibigay natin ito sa exam natin. Ibibigay ito sa exam. Because even sa board exam, binibigay ito, yung code na ito. Okay, so ano yung gagamitin natin dito? Check the VU. Okay, of course, we will always be using the maximum. Ano yung maximum dito? 1.15. Well, in this case, maximum for this slab ABDE, yung maximum dito is exterior face of first interior support. So, if ito yung slab natin, consider natin ang exterior face of first interior support, these are the outer supports, that one and this one. Ito yung exterior supports natin. First interior support dyan is this one and this one. Pareha silang first interior support. Okay? Because we are considering or basing sa outside supports dyan. If this is the these are the outside supports, then this 2 is first interior support. So first interior support but exterior face. So exterior face dito is dito sa labas. That is facing outside. On the other side, that is facing inside. Yan yung tinatawag nating interior support. Okay? Well, anyway, may tutorial ako dito on how to interpret this code. Ilalagay ko lang sa ating Moodle. Okay? Para mas makita nyo how to interpret this code. Okay? So, we will use this maximum factored shear 1.15 WLN over 2. But take note, ano yung LN natin dito? LN is not the same dito sa L na ginamit natin kanina. Okay? LN is defined as the clear distance. What do you mean by clear distance? Okay, so LN here, if the center to center length of the slab here is 2.8, then dapat i-minus natin yung half ng beam dito and half ng beam dito sa kabila. Okay, so take note that the dimension of the beam or the beam width is 300 millimeters. That's why our LN automatically that will be 2.8 minus that beam width or 0.3. Okay, that one. So that is 2.5 meters. So we can calculate our shear maximum, VU max. Okay, substitute lang the values. Okay, of course we have this WU, no? LN is 2.5, then divided by 2, we have this value of maximum shear, factored shear. Now after this, we will compute the design shear strength of the concrete. So ano yung design shear strength of the concrete? Okay, so imagine muna, ito yung cross section ng ating slab, no? So that is 1 meter strip, so 1,000 millimeters yan. Ito yung thickness. Then we need to calculate this distance, effective depth. The same lang siya sa beam. Okay? Excuse me. Busog ata ako. Okay, so how can we calculate that effective depth? Okay, so we need to assume a concrete cover. So in this case, the minimum concrete cover for slab or concrete not exposed to the weather. So nasa loob yung slab. Okay, that is 20 mm. Ito yung minimum concrete. Nasa code ito. I want you to read the code, no? Dapat mas code-based tayo para exact talaga yung mga assumptions natin. But anyway, sa problems naman sa board exam or sa exams natin, binibigay yung concrete cover. Okay? But in reality, when magde-design na tayo, nang tayo-tayo lang, then tayo yung mamimili. Babasahin talaga natin yung code. Okay, so in this case, how can we calculate the effective depth? Okay, so dimensions lang, 120 the total thickness minus the clear cover, so 20, then minus ng half ng ating reinforcement bars. So half nyan is, nagkamali ako dito. Half dito, that should be 5 mm lang pala. Dapat minus 5 lang to. Nadiretso ko minus 10. Okay? So, masyado nang mahaba yung na-record ko. So, ganito na lang. Mag-proceed lang ako, ha? Basta may mali tayo dito. Dapat 5 ito. Ang importante lang dito is yung step-by-step solution or the analysis. Okay? I hope you can check this one. Dapat 5 lang ito. Then, i-continue nyo lang yung solution dito. Okay? Dapat 5 mm lang siya. Half to the centroid lang kasi yan ng reinforcement bars. So, assuming na lang, no? The effective depth is 90 mm. Okay? That should be 85 mm dapat. Nagkamali lang ako dito. I will just continue this one because masyado nang mahaba yung na-record ko. Kapoy na. Okay? So, 90 mm na lang yung gagamitin ko as effective depth. Okay, so, next, if I have the effective depth, then we can calculate the concrete design shear strength. And that, pag sinabing design, dapat may phi siya. Okay, phi BC. And phi na gagamitin in shear, I will just denote this one as phi sub B, and that is 0.75. Okay, iba siya sa for flexure or yung bending. Okay, ito yung formula na nasa code. Okay, so phi, by the way, this VC is 0.17 lambda square root of FC prime BD. Ito yung phi natin. Okay, dinerecho na lang natin dito. Okay, so yung lambda dito is the modification factor. So normally, pag normal weight yung concrete, automatic 1.0 yan. May interpolation dito sa code, but bihira lang natin yung gagamitin. 1.0 talaga yan normally. Okay, so substitute, we have the values here. Of course, B is 1000 mm and D is 90 mm. Okay, so PVC is 130.22 kilonewtons. Then ito yung i-check natin or i-compare natin sa maximum shear because of the factored loads. So comparing this one, VU or the maximum shear due to the factored load did not exceed ng phi BC. Okay, that means kayang-kaya ng concrete yung shear, and that is adequate. Okay, pag hindi na siya kaya, then doon na tayo maglalagay ng mga anong tawag doon? Mga lateral ties or mga stirrups. Okay, and to tell you, bihira lang na hindi kaya or bihira lang na hindi mag-adequate pag ang slab yung ina-analyze dito. Ito talaga yung most cases. Bihira lang talaga yun. Because as you can see in the formula, napakalaki ng B natin. 1000 mm yung analysis natin dyan. Unlike sa beam, di ba yung beam kalimitan nasa 300 mm, 250 mm, 200 mm yung beam width. So may chance talaga na hindi siya adequate for shear. Okay, okay, so proceeding this one, calculate, after we check the shear, then hindi na natin yun gagamitin. Dito naman, i-calculate natin yung positive and negative moments to be used in design. Okay, so ano yung gagamitin natin? So again, ito, yung code na ito. Approximate moments for non-pre-stressed continuous beams and one-way slabs. Okay, so ito yung frame natin. So, unahin natin yung positive moment. Of course, in this slab, as you can see, at the support, at this one, fixed yan. Okay? And also this one, fixed din yan. So, unahin natin yung positive moment. Yung positive moment, as we all know, that will be acting at the center or at the midspan dito. Okay? For positive moments, so may pagpipilian tayo dito. As you can see, this one is the end span ng ating slab. So, we'll be focusing on this one. This one is interior span. So, this is end span. So, focus tayo dito. So, end span. Then, may category tayo dito for conditions. Discontinuous and integral with support. So, ano yung integral with support? Yan yung naka-restrained siya. Okay? Discontinuous end. Of course, this one, wala, that is discontinuous end. Wala na siyang continuation doon. So, pasok ito sa criteria dito. Ito, discontinuous and the same pa rin, discontinuous and unrestrained, meaning hindi siya naka-fix. But as I have said kanina, fix siya pag nakapatong siya sa beam. Naka-fix yan dapat. Yan yung assumption sa code. Okay? Unless specified sa problem. So, gagamitin natin is yung nasa itaas. That one. Ito yung for positive bending. How about for negative bending? Okay, negative bending, of course, yan yung moment at the support. Okay, so tingin tayo dito for negative. So, interior face of first exterior support. So, diretso na lang ako. Yung gagamitin natin dito actually is this one. Exterior face of first interior support. Again, this is our first interior support. Exterior face nito is andito sa portion na ito. Dito is interior face yan. Okay? So, again, may ipapakita ako sa inyong video na ito which I made almost 3 months na siguro or 2 months because I have a tutorial nito sa YouTube. Okay, diniscuss ko yon on how to interpret this one. So ito yung gagamitin natin for negative bending. Okay, so ilagay ko lang. For positive, gawin ko lang MUP. Ito yon. Okay, for negative bending, I will call that MUN, which is this one. Okay, so yan yung gagamitin natin sa design. So let me go back. So ito yung for positive. Unahin natin yung positive bending. So as you can see, pag i-design natin yung slab, dapat i-design natin yung positive bending and yung negative bending. And by the way nga pala, yung i-design ko lang dito is yung positive bending. I want you to continue the negative bending. Okay? So for positive bending, that will be the value. And substitute, we have the WU. This one, nakuha natin kanina. Of course, our LN is the clear span. That one. And divided by 14. And we have that value. Napakaliit lang yan because 1 meter strip yung analysis natin dito. Okay? Basta mga slab, maliit lang talaga. Because that loads came from the persons or the occupants ng ating ng slab natin. Nasa code din yan. Okay? So, 4.5 kilonewtons meter. So, paano ba natin i-design yung reinforcing bars sa slab? Actually, the same lang siya sa pag-analyze ng beam. The same lang talaga. But, sa huli, ang i-design talaga natin is yung spacing ng bars dito. Ito. Spacing nila. So, MUN, ito yun. So, this is the value. So, I want you to proceed yung negative moment or negative design in negative bending, which is you will use this one. So I will just again I will just design the bars for positive bending. Okay, so step 4, of course, the design the reinforcement. Then again the same solution or the same analysis lang yan sa beam. Okay, bottom reinforcement, gagamitin natin to. Rn is equals to mu over phi bd squared. Okay, remember, nagamit natin to in designing a rectangular beam. And take note that a slab, the cross-section of the slab is considered as rectangle. As you can see, wala namang circular dyan or T-beam. Automatic naman siya slab. Okay, rectangular talaga yan. So, mu, ito yung mu natin na gagamitin for positive. So, substitute, of course, our phi for design in flexure or bending is 0.9. B is 1000 millimeters and D is 90 mm. Of course, nagkamali tayo dito, no? But I will just proceed because napakahaba na yung na-record ko. That what? So we have this value. Okay? After this one, ano yung susunod? Like designing the beam, the steel ratio, which is this formula. Okay, na-derive na natin to on our first video siguro. Okay, so substitute lang ni formula and we have this value. I mean, substitute lang these values dito. Okay, I know you can follow this one. Now, after this one, diba, i-check natin if magdodoble ba siya or i-check natin yung ang strain, limiting strain. But I will just use the tension control. Diba, like the beam, I will just call this one as rho max. 3 over 8 times this quantity. Okay, I hope you remember this one. Tatawagan ko na lang siyang rho max. Although hindi siya maximum because as you remember, yung strain na 0.004 correspond to 3 over 7. But in that case, hindi kasi natin magagamit yung 0.9 na reduction factor. Kaya ito yung gagamitin ko na rho maximum dito. Okay? Actually, it's up to the designer, Jod. It's up to the designer lang. But if I am to design or to design the beam or the slab for flexure, of course, gagamitin ko talaga to. Okay? And ito rin yung ginagamit ng ASEP. If we substitute those values, ito yung lalabas na rho maximum. Okay? 0.01649. Now, as you can see, the rho maximum is greater than the rho. That means okay siya. Hindi siya lumagpas sa rho maximum. Pag lumagpas ito, that means idodoble niya ito. And again, to tell you, hindi mangyayaring magdodoble yung slab. Hindi talaga mangyayari yan. Because napakahaba again ng beam width na kinukonsider natin. And napakaliit lang nung depth natin. So, probably talaga mag-yield yung strain, ang steel natin. Mag-yield talaga yan. So, pinakita ko lang dito para kuan talaga ba? Step by step talaga yung pagtuturo natin. But, in your exam, I suggest wag nyo na itong i-check yung maximum. Okay? For designing the slab. I suggest na lang. Okay. Of course, if we check the rho maximum, dapat i-check din natin yung minimum. So, the code in NSCP 2015, ito yung sinasabi niya. So, sa code, AS minimum na siya, hindi rho minimum. Okay? Now, as you can see, in these formulas here, as you can see here, that the factors are multiplied by area gross. Area gross. So, ano yung significance dito? So, di ba, pag we say rho, that is AS over BD. But take note that BD is not area gross. That is just the effective area of the concrete. Up to D lang. But sa rho minimum, AG yan. Yung AG is B times the total depth, which is 120. Kaya, we need to compare this minimum to the area of the steel bars. Hindi natin i-compare yung mga steel ratio. Okay? Ang i-compare natin is yung AS talaga. Okay? So, ganito yan. So, this is our rho. Of course, nakuha natin to. Then, i-compute natin yung AS. That is rho BD. Okay? So, substitute. Of course, we have this value of AS. Then, ito yung sinasabi ko. Kukunin natin yung AS minimum. And by the way, gagamitin natin to. As you can see, our FY did not exceed 420 MPa. So, we will use this one. Okay, basahin nyo lang yung code dito. For the form bars, greater than. So, ito yung other cases. Okay, you can just interpret this one. Madali lang to. Okay, so in this case, ito yung gagamitin natin. So, AS minimum is 0.0020 multiplied by the area gross. Yan yung gross area ng cross-section natin, which is 1,000 times 120. Okay? Kaya hindi raw yung i-compare natin. Because yung AG natin, as you can see dito, yung area is 1,000 times 90. Dito is 1,000 times 120. Dito tayo magkakatalo. Okay? So, ito yung AS minimum natin. Now, yung AS natin did not go lower to the AS minimum. That means that is okay. Pasok tayo sa code. If bumaba siya, again, dapat AS minimum yung gagamitin natin. Okay? So, final step in design, i-compute natin yung spacing of the bottom reinforcement. Ito, spacing nila. This one, spacing, center to center spacing yan. Okay? So, we can calculate that. Actually, this is just the ratio and proportion. No? AS, area of 1 bar over AS, multiplied natin by 1,000 millimeters. This is just ratio and proportion. Ito kasi yan. In every spacing, in every 1,000 millimeters, we have spacing, ganito yan, S over 1,000 millimeters is equals or lesser than to area of 1 bar over the AS. Well, anyway, gamitin nyo na lang to. Parang na-confuse ako. Okay, gamitin nyo tong formula na to compute the spacing of these reinforcing bars. So, that should be lesser or equal. Okay? That is, of course, mas safe yung slab natin if magkalapit yung mga bars natin. Okay. So, substitute. Okay, so area of one bar, we have 10 mm diameter here, so pi over 4 times diameter squared, divided by the AS, which is in this case ito 354.87 multiplied by 1000, and we have the value of the spacing. Okay, so ano yung gagamitin natin na spacing? So I will just use 220, that is safe na. Okay, bababa lang. Of course, pwede rin 215, 210, because in this criterion dapat hindi siya lalagpas dito sa 221.32. Okay? That means pwedeng bumaba. But of course, we need to consider the economical factor dito. Pag masyadong magkalapit yung bars, that means masyadong marami yung bakal. So, mapapagastos yung may-ari ng bahay dyan. Okay? So, I want you to continue to design the reinforcement on the top portion for negative moment. Okay? That is for you to practice. Okay, so maybe I will end this video right now.